So let's take a look at radical 4x squared. This is the same as radical 4, the first term, times radical x squared. The square root of 4 is equal to 2. The square root of x squared is equal to x. So the square root of 4x squared is equal to 2x. Now we can also wind up with the negative radicand. If the radicand is negative and the index here is odd, then the final term will be both real and negative. If the radicand is negative and the index is even, then the final term will be imaginary. So we'll take a look at that in a second. So let's look at this first concept. The index is odd. So the cube root of negative 64 is equal to negative 4 times negative 4 times negative 4, which would give us negative 64. So what times itself 3 times would give us negative 64? That number would be negative 4. So that's a real number, and it's negative because our radicand was negative, but our index was odd. But if our index is even, it's not real because there's no number times itself that will give us a negative product. Positive 8 times positive 8 is positive 64. So the square root of 8 times 8 is not equal to the square root of negative 64, nor is the square root of negative 8 times negative 8, because that would be positive 64 as well. So instead, what we have to do is we have to extract that negative 1 times 64. So this would be the same as the square root of negative 1 times the square root of 64. The square root of 64 is 8. And the square root of negative 1 is called the imaginary term. So the square root of negative 64 is 8i. Right? This is imaginary. So this is how we deal with negative radical terms. We extract the negative value, and the square root of negative 1 is equivalent to I. The square root of negative 1 is equal to the term I, which is our imaginary unit. Now this leads us to complex numbers. A complex number is a combination of a real number and an imaginary number. Either part can have a value of 0, so all real and all imaginary numbers are complex numbers as well. So 7 plus 4i is an example of a complex number in its most simplified term. These two cannot be combined because this is real and this is imaginary. 6 plus 0i is equivalent to 6. 0 times anything is 0. But the term 6 is equivalent to 0 imaginary values. Right, so this is more semantics than anything, but it's just another example of what our final answers will look like when we start simplifying radical terms that have negative radicands. Imaginary values come into play. Another example, 0 plus 7i is equal to 7i. Now, when we wind up with an answer like 11 minus 9i squared minus 8i, we replace I squared with negative 1. 11 minus 9 times negative 1 is negative 9 times negative 1, which is positive 9. Positive 9 plus 11 is 20. So this would simplify to the complex number 20 minus 8i. Now let's dive into this concept further of simplifying imaginary units. Imaginary numbers with an exponent larger than 1 can be reduced by replacing I to the power of 2 with negative 1 and I to the power of 4 with positive 1. So we've established that we're using I, the imaginary unit, to help us deal with negative radicands. So I is equal to the square root of negative 1. I squared, any square root times itself, is simply the radicand, negative 1. Do not confuse this with this. The square root of negative 1 times the square root of negative 1. Negative 1 times negative 1 would be positive 1. So the square root of positive 1 would be 1. So when you're dealing with complex numbers and imaginary units, some of our conventional rules do break. So I just want to point out, when you are dealing with I squared, do not replace it with positive 1. We are dealing with this. The square root of negative 1 squared. It means we simply remove the radical, leaving us with negative 1, not positive 1. I cubed is equal to I squared times I. I squared is negative 1. Negative 1 times I is negative I. So I cubed can be simplified to negative I. And I to the fourth is equal to I squared times I squared, which is negative 1 times negative 1, which is equal to positive 1. All right, so that is how we simplify larger imaginary units. Let's have you do a few practice questions. Simplify. Question number 1, the square root of negative 36x to the 6th. Question number 2, the square root of negative 25x to the 8th. And question number 3, 3i radical negative 5 times 2 radical 6 minus I radical negative 7. Pause the video, answer these questions, and then press play when you are ready to begin. Question number 1, step 1, remove the imaginary unit from the radical. So we have negative 1 here, so we take that out. So now we have a positive radicand. Step 2, we simplify the radical. So we replace the square root of negative 1 with I. So we have I radical 36x to the 6th. So now we want to simplify the radical term further. Step 3, remove a factor from the radicand that is a perfect square. So that would be 36. So we take that out. Radical 36x to the 6th is equal to this factor times this factor. So that's how we get radical 36 times radical x to the 6th. Now we simplify these radicals. The square root of 36 is 6. So we wind up with 6 times I, which is 6i. And remember, the square root is equivalent to having an index of 2. So the square root of x to the 6th is equal to x to the 6th to a power of 1/2. So we wind up with 6 times 1/2, which is 3, leaving us with a final answer of 6i x cubed. Question number 2. Step 1, remove the imaginary unit from the radical. So we take out negative 1, and then we simplify the radical to I, leaving us with I radical 25x to the 8th. And now we simplify this further. So step 3, remove a factor from the radicand that is a perfect square. That would be 25. The square root of 25 is 5, leaving us with 5 times I, which is 5i. This index is 2, but it's not shown, it's 2. So x to the 8th to a power of 1/2. Power of 1/2 is the square root. 8 times 1/2 is 4, leaving us with the final answer of 5i x to the 4th for question number 2. Question number 3, we had to distribute our term on the outside to each term on the inside of the parentheses. Step 1, distribute the term on the outside to each term on the inside of the parentheses. So we multiply our coefficient, 3i times our first coefficient 2, which gives us 6i. We then multiply the radicands of those terms. Negative 5 times 6 gives us negative 30. And then we repeat that process with this term and the second term. So 3i times negative I gives us negative 3i squared. And then we multiply their radicands. Negative 5 times negative 7 gives us positive 35. So after step 1, we have 6i radical negative 30 minus 3i squared radical 35. And now we want to simplify these terms even further. So step 2, remove the imaginary unit from the radical. So we take this negative 1 out and we replace it with I. So 6i times I gives us 6i squared. And over here we have minus 3i squared still. And now we can replace each I squared with negative 1. So 6 times negative 1 is negative 6. Negative 3 times negative 1 is positive 3. And since we cannot remove a perfect square from either of these radicands, this is the most simplified version of our expression. Negative 6 radical 30 plus 3 radical 35.